Okay, hello, welcome to the first talk of the revision. I'm here as a replacement with my talk Bang or How to Make a Demo. Last year I won the old school competition with the demo Bang, and since there's been only a very few documentation on things done, and there are some guys at universities who are deeply into also analyzing how demo coding works or what it is, then I started to make something for them, and so I'm going to present it here right now. So, what is a demo? I think we can skip this one since everybody who is here should know. What is needed? We need music, graphics, code, and sometimes some guy who coordinates if the project gets bigger. We were 5 people, so I also, writing the code, try to coordinate all the guys. Let's get a bit into deeper. The music, of course, is very important. If you got good music that keeps the beat of the demo, then it's much better to view or to enjoy than a demo without some tunes. And I had was very lucky because a very good musician found me 2 years ago on the revision on packing my stuff at the end. There was some guy who heard, just talking to me, I want to do a demo, and he said, oh, do you have, I always wanted to do music on the 2600, but had no opportunity. Would you like to do it for me? And this was Skyrunners, and he won first and won second place in this year, so he got the job without further questions. Graphics, it's hard to separate code from graphics on the VCS, so that's a bit different to get things into, and I had a lot of guys who were helping me, and that was also a bit of a lucky strike for me because the guys who provided me with graphics weren't available all the time, but I always had someone I could ask for, oh, for this part I need graphics, hey, do you have time? No, I asked the next one, he had time, he could provide me with something. And I also had some ideas on who should make graphics for what part. Okay, I did the code, so let's start with the first important part, music. Good music makes a difference. Up till now, if you want to do music on the VCS, it also includes coding your own play routines, your own tracker-like stuff. And there is the music kit by Paul Slocum, and I decided to write or to code an editor that's very faulty right now still, and but it got the job done, so that Skyrunner didn't have to put up with any coding, and he just could set stuff like that, or set the nodes in. This is the editor. It's already available as open source and some binaries for Windows, Linux, stuff like that. And, but it's not very well announced, so if you want to do something, if you want to help with the code and get it bug-free, because it's full of bugs right now, and on several levels, on the level of sound emulation, on the level of editing, and it's written in Qt, and if you've got some experience and want to help, you're very welcome. So, let's talk a bit about the hardware, because this is what really makes this demo, from my perspective, interesting, because the hardware is very limited. You've got the processor, which is the 6507. It's a 6502 with less pins and some features stripped out because of the missing pins. The television interface adapter. This is the chip that provides graphics and sound for, back then, the television. And Riot is this chip that does all the rest. It provides the RAM, the amazing 128 bytes, one timer, and it has also, it's sendable of capable of sending interrupts. The processor isn't capable of receiving them. And since I had trouble with the less amount of RAM, I used an external RAM chip inside the cartridge that was also utilized in the mid-80s by original Atari games. So this got me some 120 bytes of extra RAM. So graphics is done by the TIA. The TIA not only only generates the graphic, but does not run anything. So you can't just provide anything in there and say, let's move a sprite from A to B or something like this. It's just driven by the CPU completely. And the CPU runs at 1.2 megahertz, which is about 20% faster than the PAL or the C64. For this one, I needed a very basic trick, or to get things done. I'm using tables as functions, because we own 8-bit systems. A table can be at max 256 bytes. And so I've got something I want to do, a sinus function, something like that, a sine function. Then I would just throw in a table, or a color table, color conversion. I would just throw in a table. So I need some ROM, but it's extremely fast. It's the fastest thing you can do. It's just reading out of a table. It's something like 4 clock cycles, 5 clock cycles. So the graphics hardware. Before we can get into depth, I want to show you about what is the tier about, what are the limitations. There will be on Sunday a talk with me going more into depth of this one, because the system is, from the software point of view, really is fucked up. And there's a course for it, and if you want to know, visit my talk on Sunday. So the main difference. This was just an experiment to show the basic difference of something like a C64 or in the VCS. I just wrote random data inside the graphics register and then ran an endless loop. And on the C64, you still have something like an image, or something. You have something that's 2D. If you two-dimensional. If you take a look on the 20, it almost looks like a barcode, since it's just one-dimensional. This means each line gets drawn like the last line until I change the registers of the graphics chip. So this is something that's been done very different from every other system I encountered so far. And if you want to know why this is, also visit my talk on Sunday. So if we're going to take a look on how a picture is displayed, then we're going to have to go back in time to when the Atari VCS was developed. The only thing you had for providing a picture and stuff like that was a television. Television, you've got the CRT, and it works like you've got a beam that travels along, and changing the color of that spot where it's right now. Then it goes back to the next line, draws the next line, and so on and so forth. This is on the PAL system, 312 scan lines. This demo only runs in PAL. On an NTSC system, you've got 50 lines less. Across, since I told that I'm gonna, the mean materials across, there's something like color clock cycles. The system does not have a frame buffer, so pixels wouldn't be the right description for this. And the CPU clock cycles is divided by 3 exactly, because that's done by the graphics chip, the division. And we've got a vertical zinc. These are the rough figures about what the demo uses. This is the area of the television that's probably usually not seen, the overscan area at the bottom as well. And on the left side, we also have some horizontal blank, where also no data can be displayed. That leaves me with something like a drawable area of 160 color clocks. So this would be the maximum resolution on the X. And on the Y, we've got about 250 lines. Since I am free to decide on how many overscan lines and how many vertical blank lines, this varies from part to part a bit, because sometimes I need more time to calculate, because all the calculation what should be displayed in the next frame is done in the overscan and in the vertical sync area. In the overscan also the sound is played. And while I'm in the drawing area, since I have to rewrite the register every line, I've got no time to calculate something in there for what should be displayed. I'm just pushing the registers. This is also something that's very different on the 2600. This is something, if you do, you can do out of extraordinary effects on the C64 if you go really changing the registers while the beam travels along. On the 2600, this is mandatory. So instead of running the graphics frame by frame, the image is drawn line by line. And there are no, as I said, nothing shot. And there are no registers for the Y component because we don't have a Y. We only have the line in VR which in, and we have to keep count on where we are. So an example and something a player split is 8 bits wide and can be as high as the screen. So I can do something, and this is also something why a scroll text usually is bottom up, something like this, instead of left to right, because you have just one sprite to use for the whole screen and then can push in your graphics data in there. So, and it's called raising the beam when you paint while, if you change what, need to tell the chip what to paint when it's painting already. So, we've got about 2 different kinds of graphics stuff that can be put on. The one is called Playfield graphics, that's some kind of a background. We've got a resolution of 40 bits. With 4 color clock cycles, we have got 160 right along, so divided by the 40 bits, we've got 4 color clock cycles, so it looks much more blocky than the player data. But the player data only is, you have only got 2 sprites, we can do this later on. We've got 2 colors and only 3 registers for this one. So how are we going to squeeze 40 bits of resolution into 3 bytes? We've got a control register that shows that we can decide on should the right part of the playfield be reflected or should it be repeated. So we can decide if we want to mirror or we want a repetition of what was on the left side. This is something that's most times very annoying, but at least there's one part where I'm really gonna make something out of it. So, and these are the registers in depth. We're gonna see the 20 bits of data in there and how they are displayed on the screen. Usually you would say, okay, it goes from the alphabet through. No, it doesn't. There's only one thing that goes through and the others are reversed. And if you're gonna mirror it, then they're gonna get it back reversed. So sometimes original and then the other part reversed. If you're gonna repeat it, it's repeated. And what you can do, you can, once the first data has been done, you can change the register to display something else. And then you can get 40 bits, but this costs an immense amount of CPU time, which you need on drawing the stuff. So you can't do much more else if you're gonna go for this playfield. We've got 5 sprites. 2 player sprites, 2 missile sprites, and 1 ball sprite. The names come from the games Combat, it was Tank in the arcade, and Pong, it was Video Olympics on the 2600. And this is the ball sprite, we've got the player sprites, and the missile sprites. So it was only intended for running these 2 games, and if the designers said, if we can run these 2 games, we can run a lot more and then get the versatility out of the software. And they were right, we can really get much out of it. But they did something very, very nice because they did, sprites can be repeated, or they can be stretched. So you can get sprites up to the resolution, or the lower resolution of the playfield, and you can get sprites with a double resolution or with a sharp and then repeat stuff like this. And there are 2 things that are very nice to have in this thing. These are the ones where you have an even spacing of this. Because when you have 2 sprites, they are 8 pixels wide. When the beam travels along, you have just amount the time to change the data while it's in there, so you can put the 2 player sprites in repetition, and then you have 1 sprite that's 48 pixels wide. And this is the maximum resolution you can get without any flickering. You can also go for interlacing so that you display every other frame, 1/2 of the sprite, then you can get up to 96 pixels. So this is some kind of a maximum that can be achieved. The others are something like optical illusions. So how are sprites placed on the screen? This is one of the major fuck-ups if you look at the software. As the beam travels along, you have to trigger a reset register that says, put the sprite right here. You have got no value you can write into, so if that's to increment or decrement, you have really to wait until, then trigger it and then you have got your sprite at this position. And it's not, but since it's the beam as it travels along is in the resolution 3 times as fast as the CPU, you cannot get it in between these cycles. So you've got another stuff that you can do. You've got a motion register, so you can move a sprite from 8 to 7 bits in either direction, and also negative moves to the right, which is, if you think of a mathematical way of displaying numbers, which is really odd. And it only prepares the sprites to move. The right in itself takes place when you hit a strobe register. And then all the sprites movements are applied at once. Colors. We've got 4 color registers for the background, so that's the stuff that there's no pixel is set or no graphic data is set. We've got the Playfield, the background data, and the 2 players. And each color can be picked out of a palette of 128 on an NTSC system. It looks like this. A PAL system, since color generation they are a bit more complicated, they sacrificed some of the transistors defining the colors. So we've got about 104 different colors, but still we are lucky. The guys have got a CCAM system, they are screwed. Okay, these are the registers. We've got a Playfield. The color, the Playfield also changes, shares the color with the ball. The player and the missile sprites also share the same color. And there's also a special mode where you can say that the left color, that the left side of the screen should have the same color as the player 0 and the right side as the player 1. This is originally intended for scoring mode. As you take, if you can remember the combat, the numbers up above were in colors, and these are taken from there. So now let's go through the demo part by part. Usually I would run the demo here first, but I'm also talking fast because time is of the essence. The talk was about 75 minutes the first time I held it, so I need a bit to rush through. Sorry. So I'm going to show you screenshots of each part, and 2 screenshots per part. One is shown as the demo is displayed, and the other is some kind of debugging mode of the emulator, where every object has a fixed color. It's wonderful to figure out on how they did it. It's really fun if you don't really have an idea on how a demo is done. Toggling that mode already gives you an insight instantly. It's very, very fun to do. So we've got here the intro. This is something I had as an idea from something like the Game Boy, stuff like this, where a logo runs in, something like this. And this was intended to be just very compact. So the graphic is calculated on the fly, just by bit shifting and counting stuff. And it's only done, as you can see here, just by using the Playfield. And the colors are also adjusted on the time as that thing is displayed. Then we've got the film countdown. The whole demo is intended to be to remind of a film with several independent chapters, something like this. And a film, usually, as you know it from school, films you view in a school with something like the 8mm stuff like that. There's some kind of intro and there's counting down. And I also did this one here as well. And I also wanted to have some fuzz on the lens. This is the line here that moves and flickers around. I really like that idea. And so, hey, you've got it back in there. No, it's intended to be this way. And it's done. The circle is done using the missile sprites, and the number in itself is shown using the player sprites. So then there was something as on film, something like a prelude, something like this, or an introduction, a short before the title comes in, like in the Bond movies where you have the first cool stuff that James Bond does. Okay, it's not as cool as James Bond, but I also want to have something to put in a statement out there. And this is also the theme of the demo. Edith Piaf once said, use your faults, use your defects, and you're going to be a star. And this is what I try to do with this demo. I try to use the limitations of the 2600 as much to my advantage as possible. The Piaf itself, it's drawn as a 96 pixel sprite. Here I'm going to, on the emulator, I'm going to use something called, or I'm going to use a mode that's deflickers the data. And on the debugging mode, I switched it off on the debugging colors. So as you can see, I'm really drawing just every other line, and in itself, by interlacing, it becomes a full picture. Then we've got the first, as the production companies on the film, I wanted to have someone presenting that demo. So I had asked the guys at AtariAge, can I put in a logo of you in there? And they said, okay. And also, this is done just, these graphics are really coded. It's not something like it's drawn. I really sat there and wrote code that moved the sprites to the left and then changed the graphics data in there. And also the circle was drawn. And I also had some kind of miscalculation because the sprite is here a bit smaller than it's above. So it's not even a round circle. It's not even an oval. It's just some egg-like form. OK, it's Easter. The other one, Pue, there I didn't ask because I think I'm also kind of that scene, so I just said we are presenting it since it is a demo competition. And here I used a lot of Playfield data, but to make it appear that I have got a higher resolution, so I'm using a fall effect to get something. I used sprites in there to create the illusion that I've got a higher resolution that I really have. That's done on some kind, done with a great favor at some demos. Then also had Mega, who will also Kane of Mega will be introducing a talk here, and there I was very proud. I did a 49 pixel sprite. I used the missile sprites additionally, and I really managed to squeeze the remaining circuits, CPU circuits cycles out there, just to get this data also displayed. And the first thing I had heard, oh, our logo is so small. It's a technically most advanced thing for all the intros. And the first thing I, oh, it's so small. Yeah, it's small, but it's really, it's the coolest part. I was really proud of that again. So let's go. XAYAX, the logo. Since it was my first demo, I decided, okay, I organized it, I need a name for the group. We were going to put in there. I really wouldn't want to have a group, more some kind of a roof where people work together, so everyone's invited, stuff like this. And I really was, XAYAX is a, you can think of it as an acronym for it's good to display on a 2600. Every letter and the combination was chosen just to make it look good on the 2600. So the Y, I'm turning from the sprite resolution, or sprite repetition, from 3 to 2 with a white there, and then moved the remaining ball sprite in there, and all the other stuff. It's really done just so I can get something done that doesn't look, that's from a VCS, but it looks like it's done on an 8-bit computer. And this is also something that Jack likes to say, a very good VCS demo doesn't look like a VCS demo. So, bang, the title. This is really the title of the demo, also intended to be like a film intro, stuff like that, also with the bars in there, so you get the 16:9 flare, and again with fuzz on the lens, and also for the falling sprite, I used the external RAM because I didn't get to I needed to calculate on when to display, when to start displaying the exclamation mark, or each letter that falls off, because each letter is falling off one by one. So in this case, the exclamation mark, and but I didn't have the cycles, so I put in all the data from the start to the bottom and just read them out and calculated them up above here on what to display. So, and this one was done on Evoke 2013 when my hotel wouldn't let me in because they gave me the wrong key. Okay, then we start going up to the chapters. The first one is the 48 pixel scale. This is the maximum resolution you can get, or the maximum high resolution you can get using all the sprites. And I wanted to do a sprite that goes from all the right to all the left. So I started a bit like, I wouldn't say it's cheating, but creative, using what goes from right to left. I just made something of a stair. So if I'm going to turn it around, I only have a maximum of 48 pixels at a time at one line. And this is what the VCS can do. And this is also something I try to use to think out of the border, around of the borders of the 2600. Yeah, and this was the first part that also got me using the extra RAM, because the graphics data I'm going to need for displaying all of the stuff there are already 216 bytes. So that's much more than the 128 that I can do. Then chapter 2.1, the matrix. This is a typical matrix effect, and there I'm going to use also a trick of the VCS. Or I'm going to use a disadvantage of the VCS to my advantage. If you can take a look, there are always two dots and one line, or more. There are also, so I'm using Playfield repetition, and in the motion you really don't notice it. If it would have been mirrored, you might have noticed, but at repetition it's really hard to notice. And what to draw. I'm using also the feature of the graphics chip that it displays the line like the one before if I don't change the graphics data. So in this case, while the dots are displayed, I'm calculating the bit arrangement, the pixel arrangement on or the bit pattern on what to display now, because my graphics data in the RAM is I've got every block, I've got one thing, and that moves from top down and not at some uneven speed. So my graphics data is in the RAM of 20 bytes on how deep it is. But it's then I have to turn it something like 90 degrees around, and this calculation has been done while it's being displayed. Chapter 2.2, Bresenham. Bresenham is the classic line algorithm. That's the best thing you can get, and I tried to figure it out on if I could do something with it displaying sprites. And I really had something we had the idea of just triggering the strobe register after I've prepared on which to move, and it worked out really well. And I also had the time on displaying some data. As you can see a bit, this one is a bit lower. It bounces up and down, it gets stretched. And this is also something where the name XAYAX comes good in, because you can mirror it in the middle, so I don't have to only have to display one half, and the other half gets mirrored by the Playfield. Again, I'm trying to use the disadvantages to my advantage. Rotation text. There I'm going to have some kind of the typical bar that moves around and displays a new letter every time a new surface is shown. You've got some color shading in there that's been calculated, and it's really gone there in depth. And this time I'm not using Playfield data. Even though it's a very bad resolution, I'm using a sprite in maximum expansion. And a lot of things is done using macros and tables, and it was not nice to debug. So, okay, we've got, now we're going to get to the plasmas. Again, reusing the graphics data because ROM is scarce. The demo in itself had about 30K, and that was all I could get for my graphics data. So I reused stuff a lot as possible. And also I'm using tables for the zine, for the sign function I'm going to use, and for the color table. Now let's get to the color table. I decided on when to display stuff. I wanted to replicate the NTSC color table, since it's the best thing you can get on the 2600. On the original PAL, we get something like this, and I wanted to get there. The first thing I did was reordering of the colors, and it looks like this one. I've got a replication on the greens and on the yellows. It doesn't, or if you go ahead, I would have gone for the black and white. It really, you really focus on this one, that there's a lot black and white stuff in there. Repeating the yellows and the greens is the closest thing you can get to the original. And it's also, you don't notice it much, the repetition of this, as much as you would from the black and white. Then I had another idea to get a more fluent impression of the colors. If I'm gonna not only get it brighter, but also to get it darker again, since the lowest bit of that describes on how bright a color is wasn't used. So in my table I'm going to reusing it, and to get there a nice impression that the color gets first brighter and then darker again before changing to another color. For the 2D plasma, it's roughly the same, but in a different algorithm for displaying or for calculating, since it's two-dimensional instead of just raster bars. And part of the code is copied into the 2600 RAM for modification. Since I could, then I've got something like code that I could modify to display on which color to display. Because it's calculated on the fly, and I really needed every cycle I could get. And the illusions of the panels there, this is also something that I'm a bit proud of, because you get illusion that each panel is 16 pixels wide, minus the 2 pixels for the black line. But underneath, you see there are 15 pixel, 18 pixel, and 15 pixel, since I could only change the color at the multiplication of every third color clock cycle, because the CPU only runs at 1/3 of the speed, and I'm changing the color on the fly as the graphics data is displayed. Chapter 5.1, the Amiga disk. This is roughly the same as the Edith Piaf at the beginning. It's the same stuff used, and because of the stuff there, this is something I call the bad line. When you move the sprite for interlacing and stuff like this, then you get the first 8 color clock cycles. They are displayed in black. This is a bug in the hardware that's never been fixed, because when they did it originally for the games, the player sprites were only set in a place where you couldn't see it. Changing it on the fly as it's been displayed, this has been done later, and at this time the hardware was already in a state that's been called finished. So, the Amiga board. This is also rather a basic stuff to do. It's just a 48 pixel sprite. This is one of the things that you code something like the third thing you try if you're going to really get into depth of 2600 coding on how to display a sprite, and that's going to be a movable. I really used Blender to generate the graphics data. I found a project that was going to display this stuff and calculated this one down, moved it because ROM is of the essence. There's really a few stuff. Moved down to 6 animation frames, and an additional one for a revision logo that pops up irregularly. And the cosinus for the bounce, what the ball does, is also pre-calculated this time instead of using a assigned table. A guru screen to end the Amiga part. This is also something, this is exactly the 48 pixels I have for high resolution. And I wanted to squeeze guru meditation in there, and I really had no idea. I figured I was there with a pixel painter and painting it, and no, wouldn't fit. If I can do, no, wouldn't fit. And then I just say, okay, I say, guru, you know. So Again, I tried to put out a plan for something that I couldn't do in hardware. There was something like 2 pixels missing or something like this. It was really annoying. And the code for displaying is shared with the one from the next part, the loading screen from the C64. The next, this chapter 6 is trying to recreate a bit of the C64 area, which is also not quite easy on the VCS. I had to put in also some workarounds in there. I had no space for the stars. I just used Playfield graphics. Also, the messages were much tighter. And I couldn't load from disk because searching for anything, searching for star, would be too much. I couldn't display it in these 48 pixels. Again, I said, OK, I'm going to load from tape, and then blanking the screen as tape loading would do, and got back to this one, said, OK, this is really some old stuff. And also, I assumed that the play on the tape was already pressed because there's no press play on tape. And from the old days, I knew if you had the play already pressed and the tape was stopped and you would tap and load, then it would already go into searching. So I'm historically correct in there. And also note the little @ sign at the bottom right for the XOMizer decrunching. So again, something top down. I wanted to have the illusion of something jumping, and the shadow is the one that goes back in there. And this was an idea I got from viewing the website from Demo of the Year for the C64 competition. And I really liked the idea and was wondering myself, like, can I do something on the VCS? And it turns out I could, but it was really hard because I needed 4 separate kernels or stuff that displays the graphics data on how much on how I had jumped for the fine resolution. The bigger resolution wasn't a problem, this was just an offset, but the fine resolution was something that I needed a different routine for. And in this case, you can see I'm going to write 3 graphic registers with the same data, just delayed, for both sides of the sprites, and the Playfield gets mirrored in itself. But I could also use a feature of the 2600 because I can mirror the player sprites. So it was originally intended that that with something like a cowboy, there was some games that if it turns around to shoot in the other side, you don't have to put in the graphics data for this one as well. So we've got a single bit that mirrors the sprite in hardware. Some of the very few features of this chip. This is the part I'm the most proud of. This is a sprite multiplexer showing 10 sprites, where I've only got 2. And it took me 5 attempts and 3 weeks to get this one running. And from the first idea, I had some concessions to make because, as you can see, this is the maximum width that they can be around, or the maximum width that they can be. This is the maximum left, this is the maximum right. So, because I needed this space here where I'm going to do some calculation on what to display next, as well as I'm going to need this one here. So this was a really tough case, and this also got a bit it looked really nice, but since only a few people really know of the limitations, I know of only one who really congratulated me on this part. And this is what I thought was the wow effect of the whole demo. So, okay, the next part. Impossible Mission Man. I had the idea, again, trying to use to do something that on the first thing you could think it couldn't be done. I wanted to have a sprite that looks much bigger than it is on possible with doing just by combining 2 sprites, these 16 pixels I have. So the idea on the TRSI demo, AtariAge, there was a sprite of the Armor-lights moving around. Thus I said, oh, this looks fucking great, and I need something I can hold against this one. Since I never really played Armor-light, I went something for one of my favorite games, and that's Impossible Mission. I tried to recreate the sprite, and I really could do it just by attaching the sprite and moving it along as it was displayed. And the cool part here, I'm going for the hand. I'm going to use a missile sprite. And I could do a running one. The somersault, no chance to do it because there were the graphics limitations so high that the sprites were too wide above. I need to have to move too many ways, so this wasn't possible. But running, this is correct by the pixel. every frame, every pixel is exactly as on the C64 version. And they're running along some kind of scroll text. But for planning on when to move a sprite, something like this is something that I couldn't done on paper. So I had the idea of writing a tool that would analyze the frames and then calculate on what to do. And then I figured out this would be a fucking amount of work. And I decided to go for something like a compromise, a tool that aids me in doing this, the intelligent stuff by hand. And this looks something like this, where you can see the sprite. This is the original one, and this is the one I recreated. And there you can see me here I can shoot the color. This is the repetition, so there's no repetition used. This is the start position. There you can see the pixels which are set. And you can see here the sprite is moving a bit, so here I'm going to use the missile sprite for the hand. This is and it's on how wide it is in this. So I just had some switches to trigger on, and I was really playing some kind of Tetris without a time limit on how to put this thing together. Okay. Also, if you ask, you can get the source code for this one as well, and I will help you to try if you got any problems, but it isn't also completely bug-free, I think. But it's the one that's most mature, at least. Then, the part I was also a bit proud of boarding Orion, I really liked the idea of, since when it's, well, Raumpatrouille Orion was one of my favorite TV shows ever. And I had the idea, okay, I've got the Impossible Mission men, but something that they wouldn't expect that they aren't really from Impossible Mission. Since they are black and white, let's use them for Raumpatrouille. This would be cool. Also the alarm start, that's also been a term that's been really used in there, in the original series. And then they are boarding in there and flying up. I thought it was a nice thing to do. And I also had a discussion with someone my age. Yeah, but the young kids don't know Raumpatrouille Orion. I said, okay. Then they see a saucer flying up. So what? But this is something I also do. If you can find something where you feel you're a bit special, then I've done my work. So, and then when it moves up, then we're going to get to the greetings part. The saucer flies around, and this is also a part, this snow or stars effect. There are 3 different stars that are moving along in a parallel scrolling. This something like this is what I'm using there is a bug in the hardware. Something that's been declared stable. It's working for most of the hardware. In my case, how I'm using it is all of the hardware really I encountered, and the same. It's also working the same way. And the stars are spraying across. This effect has I discovered this bug in the hardware by accident. Only something like 30 years. 35 years later, 30 years later, then a developer from Atari or Imagic, as he moved to this company, did the first time. So then I had the flashback. So okay, you've encountered something like this before, and okay, I tried and looked at his code. It wasn't really good to read from the assembly, so I decided that I would write a small cartridge where I can fool around with the parameters and see what's triggering this one more in detail. And I figured out that I could do 3 sprites at once. The original cartridge, Cosmic Arc, original game, could only do 1. I could do 3, and I was really proud. And then there came Thomas Jensch along at AtariAge and showed it with all 5. Thank you. And about 3 months early before I was releasing my demo. So, my snake. This was an idea. I started with having logos swinging around in a Zenus, or in a Zine table, in a Zine function. And I was wondering on how tight I could squeeze them. And after I tried this one, I wondered, how about, can I change the graphics data? Okay, or can I move the sprite as well as when the sprite has been displayed? Because if you're going to do a 48 pixel sprite, you have so little CPU cycles left that in the basic version, or the general version that's been around, you only have 6 clock cycles left for the whole line, because every other clock cycles are used just for changing and displaying the graphics. So you have got no time to calculate on what to move where, and not even to get some offset. And then I tried to optimize it a bit. I was able to squeeze out a few cycles more. And I was also fucking proud to say, hey, this is something that's never been done before. And I learned of someone who can do this one even better with stuff like that. You will see this one in the 4K compo. And I also needed the extra RAM for pre-calculating. He can do it in 4K without any extra RAM. Okay. But for planning this one, I needed to go for cycle calculation. So I wrote a tool that I introduced in an 8K talk last year here at this place that's called fridgegrid, from the idea of having grid paper and fridge magnets. So I can go, as the beam travels along, this is my left border, this is my right border, and this is where it starts displaying. So this is the clock cycles I need for this just changing the graphics data. This is the cycles I need for applying the motion data. And this is where I'm going to load the motion data. And here the move gets triggered and stuff like this. So I could plan something like a general plans with his armies and when to attack where and stuff like this. This is also the third tool I needed to write just to write a demo. So just for planning. And here you can see this is something I've put in there on when each playfield is in use, each playfield data in the repetition, stuff like that, and watch CPU clock cycle. Just as furthermore as an example. Okay, well, gets tight, I can mention. This is the less official part, the girl. Someone said if you want to win with a demo, you just gotta have boobs. These are the best boobs we could get. The idea here was also to enhance the playfield graphics on some areas with sprites, so that we can go. So we have a bit the illusion of a higher resolution, and this is on how it got done. This is what the original girl looked like, and this is just the girl in the playfield data. Also, only the left side has been taken. And this is the sprite data that's been painted in there. This is a coding of the color. So the color you see in the picture in there isn't used at all. And this is binary coded the movement on where the sprites are moved to, how many pixels to the left, to the right. So all the information on how to display is encoded in pixels. And I wrote a short routine that will strip them out and put them then together in a new way that they could be used for displaying the stuff. And since not much of the original, if you can take a look back, really got preserved. So for this one, Dev, I'm sorry. Dev was the one who drew the original girl. So now let's go to the outro. This is like in the movies, there's the scroll text where with the credits and stuff like this. And I also liked this quote. This was of the guy who did the first time the stars effect I'm going to use for the parallax scrolling. And he said the 2600 always was about who could show the coolest stuff. And our motivation was to blow each other away, plain and simple. And this is what it is on 2600 coding nowadays. We also, everyone who codes 2600 demos tries to impress the others on, oh, I didn't think I could do something like this. So Calirian did some 2 great demos in the last 12 months. And I also had to go with the debugger and the false color, stuff like that, just to get an idea on how he did it. So, also something I like in movies very much is after the credits is done, something like Lethal Weapon or something like this, there's a gag at the end which has nothing to do with the movie in itself, something like this. And I wanted to have the, again, the guy from Impossbile Mission, this time in his real do, he runs from left to right and then looks into trying to search something in the web. He never finds anything, so he is always said that the searching bar goes down and says nothing found, and in the last of the 3 rooms he searches, nothing here, and then but free beer. And that was the moment I tried, I was tossing around beer on the audience while viewing the demo. And for the last part, the outro was a small QR code that's been displayed. This one takes you to the website that's hosting the demo. On the first time it was shown here, there was just the download of the demo. Right now I've been trying, additionally to my talk here, to gather some information on where I got inspiration from. So for example, the title Bang has been really used by Frankie Goes to Hollywood for 2 albums. One is the Greatest Hits collection, one was some very obscure Japanese compilation of rare stuff. And I also tried again here at XAYAX using the mirror effect, and I'm going to also use a sprite for a higher resolution for the name of the year. So, thanks for listening. There were a lot of people involved with this demo: Skyrunner, Deft, Vito, Titos, and myself. To all of you who added something to this one, thanks. I also have to say thanks to Michael Steil, who brought me into giving talks by doing his fabulous The Ultimate C64 talk, and Ninja of the Dreams, who got me the inspiration on really doing a talk about a demo with his talk he did at the, I think it was a 28C3, also at the Congress of the Chaos Communication Noise. You can meet me at if you got questions. You can meet me at the demo parties here, VCS Dev, ERC channel. On ERC, no, that's not ERCnet, it's, you will figure it out. And AtariAge and my homepage, or the page I host all the stuff in there. I think we've got something like 2 minutes left. Any questions? Since I've been really rushing through the slides. I'm sorry for this one, but as I tried to cramp in a lot of demo in there, as a ROM, I tried to cramp in a lot of stuff in this talk.
Would you say that there's any problems synchronizing when you're raising the lines and you have to write information in time with the lines? Would you say that it's difficult to stabilize the synchronization? Because I've heard that might be a problem when you do it on the C64 to get a stable timer routine.
Yes, it's been a bit. This one is. I haven't done it on the C64 in this depth, but I say on the 2600 it's easier to do, because you have got an emulator where you can really have a debugger window where you can see the beam traveling along every other step. You can do trace next, next line, or just a CPU cycle, next instruction, and you can see as the beam travels along, and then you can see, okay, here I'm going to write something too early, too late, and this is why it is. And you also have a debugger window with the assembled code in there, and then can see on what is where the problem is. So from what I know, SvOlli of TRSI is trying to bring something of this into the Vice emulator. So I think on the VCS side we right now have a bit of an advantage there.
On C64 it's possible to use illegal opcodes. Do you have them on Atari VCS 2?
Yes, you have them on the VCS 2, and this demo was done without. Out of pure masochism, because as I was about 80% through, I noticed, oh, I haven't used any opcodes, because when I started on my C64 days back then, this was 20 years ago, and since there was no assembler that was really using illegal opcodes back then for self-hosted stuff, I only was accustomed to the legal ones. And the illegal opcodes are something oh man, I could have used them, but I said no. I put a statement at the end like, no animals harmed, no illegal opcodes used in the scroll text. So I tried again to make this flaw a pun, so for my advantage. But except for the really obscure ones like the 8B, AB instructions, they are AND with a fixed value, stuff like this. I've written some code to analyze the CPU in there, which is not really easy when you only have 128 bytes of RAM to store something. they are unstable, but most of the stuff is really stable there. So all the general ones use. It's just a 6502 with less pins. So it's the same. It's also the same size. It's even a bit older than the ones used in the C64. You have time for one question more? Okay, we don't have. Thank you.